Dear students, welcome to my video. Chapter 7 Coordinate Geometry Part 1. Dear students, do you know what is number line? Yes, already you learned number line in the earlier classes. So, on the number line we have mark 0 and right side of 0 is positive integers and left side of 0 is negative integers. That means every point has a number and every number has a point on the number line. So at that time one question is arising, how to plot a point on the plane, not on the number line. On the plane we select a point, how to locate that position of that point. That is our question. For this, we have to introduce the geometry, that is coordinate geometry. Then in class 9, we have seen that to locate the position of a point on a plane, we require a pair of mutually perpendicular lines which are known as the coordinate axes. The horizontal line is known as x-axis and the vertical line is known as the y-axis, and the intersection point of this coordinate axis is known as origin. So this plane is known as Cartesian plane or coordinate plane. So the x-axis and y-axis. Okay. So this plane is known as Cartesian plane and or coordinate plane. And also we have observed that the two axes, that is x-axis and y-axis, divide this Euclidean plane or coordinate plane or Cartesian plane into four. That four regions are called quadrant. How many quadrant? Four quadrant. What are they? First quadrant, second quadrant, third quadrant and fourth quadrant. So this coordinate plane divided into four, that are first quadrant, second quadrant, third quadrant and fourth quadrant. Now choose a convenient unit of length and starting from the origin as 0, mark off a number scale on the horizontal line, that is on the x-axis, positive to the right of the origin and negative to the left of the origin. Okay. Also mark off the same scale on the vertical line, that is on the y-axis, positive upwards and negative downwards of the origin. Then how to plot a point on the Cartesian plane or coordinate plane? For this we select a point on the plane, and here we have an example. Then first you go through x-axis and we have a point, that is 2, and write in a bracket 2 in first, and from that point again go through y-axis and you will get the point is 1 or the number is 1. So select as a second number in the bracket. So the you will get 2 1 pair, that is 2 1. Then one more example is there. So select that point and move to x-axis. So you will get a number -3, that is on the first number, and again move to y-axis, the number is -2 and this is the second number in the bracket. So the ordered pair is -3 -2. So every time we get an ordered pair, okay, the position of the point in the plane with respect to the coordinate axis is represented by the ordered pair. So we can select the first number is x and the second number is y. So the ordered pair x y. In the ordered pair, the first number is known as x coordinate and the second number is known as y coordinate. That means x coordinate is another name is abscissa and thus y coordinate is another name is ordinate. Abscissa and ordinate. So this ordered pair is known as coordinates. Okay. So let us find out the coordinates of this point. What is the coordinates? What is the x coordinate? Here 4 and y coordinate is minus 2.5, in between minus 2 and minus 3, that is minus 2.5. So the ordered pair is 4 minus 2.5. Then in this chapter we will see how we can find the distance between 2 points whose coordinates are given. For this we introduce a formula. That formula is known as distance formula. See the figure. We have a 2 points. One is P x1 y1. The second one is Q x2 y2. For the proof, we have to join Q to T and P to T. So we get right angle triangle, and this P is joined to R and T is joined to S on the x-axis. Then by using Pythagoras theorem, we have to find the distance of PQ. What is the Pythagoras theorem? Hypotenuse square is equal to base square plus altitude square. That is PQ square is equal to PT square plus QT square. Here OR equal to x1 and OA is equal to x2. Correct? Then we can write RS is equal to x2 minus x1. This RS means PT. So the distance of PT is equal to x2 minus x1. In the same way, you will get the distance of QT, that is y2 minus y1 on the y-axis. Okay, so instead of PT and QT, you substitute that values. So what happened here? PQ square is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So you will get PQ, the distance PQ is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So you will get the distance between P and Q is, or distance formula for finding the distance of PQ is root of x2 minus x1 the whole square plus y2 minus y1 the whole square, or it can be written another way, root of x1 minus x2 whole square plus y1 minus y2 whole square. Both are same because after the calculation your answer will be correct. Then we select 1.00, that is origin. The second point is xy. So apply these 2 points on the distance formula. You will get root of x square plus y square. That only in the case of origin. Start from the origin. You select first point is origin and the second point any point, you will get root of x square plus y square. Okay. So one more time, what is the distance formula? The distance between 2 points x1 y1 and x2 y2 is given by, the formula is d equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square, or root of x1 minus x2 whole square plus y1 minus y2 the whole square. Let us look one example. Find the distance between the points A minus 4 minus 1 and B 1 2. So here we have to select the first ordered pair x1 y1 and the second one x2 y2. x1 y1 in first and the second x2 y2. Apply in the formula. So what is the formula? Root of x2 minus x1 whole square plus y2 minus y1 the whole square. So what is x1 and x2? Here x1 is minus 4 and x2 is 1. So x2 minus x1 means 1 minus minus 4 the whole square. And next bracket is y2 minus y1 the whole square, that is 2 minus minus 1 the whole square. So what is the second step? Root of minus into minus become plus, so 1 plus 4 the whole square plus 2 minus into minus again plus 2 plus 1 the whole square, then is equal to root of 1 plus 4 all square means 5 square plus next 3 square. That is equal to root of 25 plus 9. 25 plus 9 is equal to 34. That is equal to root 34. Then how to find the square root of 34? Very simple. We know 34 is a non-perfect square. For this, root 34 can be written as after 34, which number is perfect square? 36. So 36 minus 2. First we write 36 minus 2, that is equal to 34. So root 36 means 6, correct? Root 36 equal to 6. Then minus. Then write the same 2 here and 2 and divided by, take the double of 6. Take the double of 6. Double of 6 is 12. So 2 by 12. 2 by 12 means 1 by 6. So 1 by 6 means 0.1666. So 6 minus 0.1666 is equal to 5.83. It is approximate value 5.83. So root 34 is equal to 5.83. Sometimes we write only root 34. Sometimes we write root 34 is equal to 5.83 as per your problem. Okay. The next question. Do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle? If so, name the type of the triangle formed. Okay. So we need to find the vertices, the given vertices form a triangle. For this, we have to find the distance of all three sides of the triangle. So PQ, QR and PR. PQ is equal to root of, and take the point P and Q, find the distance of PQ by using formula root of 3 plus 2 the whole square plus 2 plus 3 the whole square. You will get the answer is root 50. Then approximate value is 7.07, and QR is equal to root of the point Q and the point R. Distance between these 2 points is equal to, you will get the answer is root 52, and the approximate value is 7.21, and PR is equal to root of 3 minus 2 the whole square plus 2 minus 3 the whole square. You will get the answer is root 2. The approximate value is 1.41. Already you learned one result in the earlier classes. Which is the result? The sum of any two sides of a triangle is greater than the third side. So you can construct a triangle. So this the same result you can apply in this problem, since the sum of any two of these distance is greater than the third side or third distance. Therefore, the points P, Q and R form a triangle. Take any two side and add it. You will get the sum. The sum is every time greater than the third side. Okay. Then one more question is there, which triangle is this? Okay, for this we take PQ is equal to root 50, QR is equal to root 52 and PR is equal to root 2. Apply Pythagoras theorem. Let us check Pythagoras theorem. What is the Pythagoras theorem? Hypotenuse square is equal to base square plus altitude square. So here which is the greatest side? QR. QR is equal to root 52. So is equal to QR square is equal to PQ square. What is PQ square here? Root 50. So root 50 square plus next PR root 2 whole square, that's equal to root 50 square is equal to 50 and root 2 square is equal to 2. 50 plus 2 is equal to 52. That is QR is equal to root 52. That means in the left side and the right side both answers are same. So QR is equal to root 52 and the right side PQ square plus PR square is equal to, again you will get root 52. That means hence the vertices of a right angled triangle. The next problem, show that the points 1, 7, 4, 2, minus 1, minus 1 and minus 4, 4 are the vertices of a square. What is the peculiarity of a square? All the sides are equal and the two diagonals are also equal length. So we have to find all the distance of all the sides and diagonals. So we have a four side and two diagonal. What are they? AB, BC, CD and AD are the four side, and AC and BD are the two diagonal. Then by using distance formula, find out the all four sides and two diagonal. So you will get all the four side root 34 and two diagonal. The length of the two diagonal is root 68. Both are equal. So we can say AB equal to BC equal to CD equal to AD and AC equal to BD. All the four sides of the quadrilateral ABCD are equal and its diagonals AC and BD are also equal. Therefore, ABCD is a square. The next problem, find the relation between x and y such that the point xy is equidistant from the points 7, 1 and 3, 5. So here the question is given that pxy. So let us take pxy is a point. B. Equidistance. Equidistance means equal distance from the points A71 and B35. So we get a relation. What is that relation? Okay. In between these three points. Okay. So the question is given that equal distance, that is AP is equal to BP. So squaring on both sides, so we get AP square is equal to BP square. So by distance formula, we know AP is equal to, we can write the root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So AP square can be written as, just avoid root. So only AP square is equal to x2 minus x1 whole square plus y2 minus y1 the whole square, or x1 minus x2 whole square plus y1 minus y2 whole square. Only in the left side, if the square AP square, BP square, at the time you just avoid root. Okay. So here the left side, x minus 7 the whole square plus y minus 1 the whole square is equal to, on the right side, BP square. So x minus 3 the whole square plus y minus 5 the whole square. Expand a minus b whole square and a plus b whole square. The identities are already you know, and you will get the left side and right side of the equations, and solving or simplifying these left side and right side by using transforming method, and you will get minus 4x plus 8 plus 4y equal to 0. Again simplify, you will get x minus y is equal to 2. This is the relation between x and y. Then one more question, find a point on the y-axis which is equidistant from the points A minus 43 and B 65. So we know on the y-axis every point in the form 0y, 0 1, 0 2, 0 3, 0 minus 1, 0 minus 2, 0 minus 3, etc. in this way. So every point is ordered by is 0 for y. So we need to find the y coordinate only here, because the x coordinate is every time 0 on the y axis. So x coordinate is 0, so we need to find only y. For this, the given point a minus 43 and b 65 and p as a 0 y. So pa equal to pb, because question is given that equidistance. Okay, pa equal to pb. So you will get the relation is 4y equal to 36, then y equal to 9. Hence the required point is 0, 9. Thanks for watching my video. Please wait for next video. Thank you.